Good afternoon, everybody. Welcome to Open Classroom. I'm Janet Gilla, the Director of Professional Development for the Brown School here at Washington University in St. Louis, and we are happy to have you with us on Open Classroom. For those of you joining on the Zoom webinar, you likely know this about the format, but we always want to let you know we can't see you, we can't hear you, and we can't call on raised hands, but chat is enabled. We love to know what's on your mind, so if you hear something that you want to know more about, or you have questions throughout the program, please do make note of them. And I'm joined by my friend and colleague, Simruti Bhattacharya, the MPH program manager here. She and I are going to be taking notes on the questions and comments that you have and weaving them into the conversation as we go. Send a special shout out to folks that are joining us on YouTube, either watching the live stream right now or perhaps catching a recording at a more convenient time for you. We're not able to moderate Q&A through YouTube, but we are super happy that you're with us. So before we get started today, I just want to let you know what we have coming up. We're taking a little bit of a break. Give staff a moment to take some of that accrued vacation time, but we will be coming back to you on Tuesday, April the 26th. With a program entitled Suicide Prevention and Mental Health Promotion for Autistic Individuals, the Important Role of Stakeholder Engagement, sponsored by our colleagues here at the Center for Mental Health Services Research, and excited to be bringing that to you. I'll throw you a link in the chat in just a minute if you'd like to sign up for that or other programs coming up. But now it's my great pleasure to introduce today's speaker. Dr. Rupang Ann is Associate Professor of Public Health here. He teaches applied machine learning using Python and applied deep learning using Python courses. He chairs the Artificial Intelligence and Big Data Analytics for Public Health Certificate program within our MPH program, and is the lead faculty for the Postmaster Certificate in Artificial Intelligence Applications for Health Data. He's the author of more than 180 academic publications. It makes me tired just saying that. And he's here to share thoughts about why artificial intelligence is for everyone. Please join me in welcoming my friend Rupang. Take us away.
Thank you so much, Janet and Smriti, for hosting this. Let me share my presentation slides. And let me enlarge this. It's really so nice to see each and every one of you. So before we start, just a brief introduction. And on behalf of the Social Policy Institute at WashU, I want to make an announcement, draw your attention for social sector organizations. A crucial step towards improving impact is cultivating a collaborative data culture through collective vision goals. So the Social Policy Institute is going to host an event entitled Data Informed Equity Driven Cultivating a Collaborative Data Culture, where participants will identify tools and strategies for building a culture of data informed decision making, grounded in collaboration, focused on equitable outcomes. So please consider attending this if you are interested. And now let's get started. So thank you all for your interest in our Open Classroom series on artificial intelligence in social sciences. So the series aims to introduce AI, machine deep learning, to a diverse group of audience, discuss applications of AI in big data analytics, assess the use and misuse of AI in social science research and practices, and also provide implications on the profound impact of AI, both positive and negative, on today and future society. So in particular, in this talk, I would like to provide an overview of AI and also demystify some common misperceptions around it. So first of all, what is AI? So in our mind, we probably guess AI could be an almighty know-all. Maybe we could consider AI as a most sophisticated mind, maybe Sherlock Holmes plus Albert Einstein plus William Shakespeare. Or we may consider, well, AI must be a math genius, can solve the most critical and complex math problem in this world, like this. But really, what is AI? There are many different definitions for AI, and I would like to borrow Dr. Francois Collat, who is the AI pioneer and author of Keras, the deep learning library, about his definition of AI. So he said AI is the effort to automate intellectual tasks normally performed by humans. So from this definition, we will see, okay, so AI is actually not trying to solve complex mathematical questions, but really trying to do some ordinary cognitive work that are usually done by human beings. So you may ask, what are the common tasks or common cognitive functions that AI try to do on behalf of human beings? Well, for example, basic visual spatial ability, right? Being able to recognize images, visuals, audios, being to recognize directions. And another, of course, is language comprehension and speech, trying to recognize what someone is talking about, make sense of it, and also communicate the information to others. Another domain is the ability to learn new information, right? Because we human beings are very good at it. We self-learn a lot of new technologies and gradually expand our knowledge. But how to train a model, a machine learning model to learn about new information? And of course, memory. We all have good and bad memories, about our childhood, about what happened yesterday. Jen and I, we were talking about, okay, I couldn't even remember what I wore yesterday. And then how can we train machines to have the memory? That is critically important, because if the machine is memoryless, of course, they can't really do complicated cognitive tasks. And another area is creativity and imagination, right? We human beings are great at it. We draw pictures, we take photos, we have creative writing, we develop new algorithms, we apply our technologies to different scenarios. But how we can train a machine learning model, a machine to be creative and imaginative? So I would like to borrow Moravec's famous paradox. So in the 1988, the Moravec was a pioneer in artificial intelligence, said the following quote: "It is comparatively easy to make computers exhibit adult-level performance on intelligence tasks or playing checkers, but difficult or impossible to give them the skills of a one-year-old when it comes to perception and mobility." So it speaks really to the fact that actually computation, math and statistics, the numbers actually are easy for computers. But really, those cognitive tasks, those self-perceptions, those are the hard part for machine to learn. And if you ask me, where is AI, right? Now AI is really, we call it general purpose technology. It's like electricity is almost everywhere. Before you even notice that. I have to ask the question, how often do you interplay with Google and Bing and search something, right? If you do that, then you are interacting with AI because the search algorithm are driven by machine learning models. Now, if you ever use YouTube and Netflix to find videos to watch, then, well, the underlying recommender system, what has been recommended to you, is driven by AI systems. If you ever shop in Amazon or Shopify, where are you going to find the things you want to buy? They are recommended by the AI systems. If you use Facebook or Twitter, well, the friends recommendations, the news recommendations, all those actually are supplied by AI platforms. And if you use Fitbit or Apple Watch to monitor your vital, your sleeping patterns, your physical activity, well, underlying, they all use machine learning models. And not to say, almost everyone of us now have a smartphone, many of us are using maybe Alexa or Google Assistant on a daily basis, and chat with a chatbot. Recently, we have an interesting study looking at the response of popular chatbots such as Replica on those really tough questions, clinical questions, for example, the negative body image related questions. And we see how well those chatbot based on machine learning models are going to provide a response to those critical, important, but difficult to answer questions. And if you interact with the banking, you know that, well, now the fraud detection is really driven by AI algorithms. If say, based on your previous purchase and your location, in St. Louis, and just one day there is a bill coming through, say in Alaska, and then the AI system is to detect that abnormal activity and report to you to let you confirm whether this is a fraud or it is really that you make the purchase. So if you have interacted with any of this, you are always you're already working with AI systems. And previously, in the last decade, a buzzword is digital divide, right? If you we the older generation remember this clearly. So people, basically, with and without knowing how to use browser, how to use the internet, are divided, and it make a huge difference between those who know and do not know how to access the internet to get information, right? But now I would say we are just at the door of a new divide that is called the AI divide. So basically in the next 5 to 10 years, we are going to observe this divide become more and more critical. So those people who know how to interact with use AI, how to use AI technologies to inform the decision making, to access information, to assist in their work and research, versus those who do not know how to interact with AI. We are going to see this divide probably becoming more serious social, political issues in the years to come. And I always really enjoy making analogies. So, in the small talk, Smriti and Janet, we talk about, the similarity between AI and COVID. Well, maybe that is not really a good analogy. But really, I want to compare, in this case, AI with hammer, because, well, both of them, they are tools, right? So, for hammer, well, hammer is a great tool if you want to use it to nail down a nail, right? And that is great use. But then, well, hammer can also be dangerous. Some criminals may use hammer to knock someone's head, right? And what we do, well, we just make regulations, prohibit people from using hammer to knock someone's head, but promote the appropriate use of a hammer, right? We won't call hammer a evil hammer or good hammer, because hammer is just a tool, really depending on how we human beings use it. Same here. So there are misunderstanding about AI. Some will say AI is evil. Some say AI is great. But really, AI is just a tool. It's not that different from a hammer. There's no evil or no good AI, but there are differences in how we use AI for the social good or for evil things. But the difference here is, well, hammer is a very easy tool, but AI is not. We are still exploring what AI cannot do. So in this case, the regulations are always going to be behind, right? Because we are going to explore new ways to use AI. For example, using AI for facial recognition, for tracking, say, people's location, and then, well, when we find that it's really, interfering with people's freedom and interfering with people's confidentiality, and then the regulations would come behind it, right? So because AI is constantly evolving, it's much more difficult to regulate AI activities. And that is the reason why we talk a lot nowadays about responsible AI, holding AI responsible, and reduce the bias, and negative social consequences associated with AI. And another misperception is AI is going to taking over the world, right? That is something, when I was a child, I was fascinated. I was really concerned about one day the Terminator would come and pursue me, right? And then I also want to borrow, the famous philosopher Rene Descartes. His famous saying is, "I think, therefore I am." Right. So it means that if someone can think, then that person or that thing must exist. Right. But really, is AI taking over the world? No, here we have to make a very critical differentiation here. So AI is intelligence. There's no question about it, right? That is the reason why we need AI to do cognitive functioning that humans often do. But intelligence is not equal to self-awareness, meaning that you think, but you may not be. So it means that, well, think about why people do evil things, because, well, we sometimes are selfish, right? And I want to say maximize our own interest because, well, I know the existence of myself, right? But, well, AI actually does not have common sense. AI does not have self-awareness. Even the most advanced AI actually, the underlying algorithm is trying to minimize a loss function. Loss function is just a mathematical function that we try to minimize. That's all AI do, no matter how advanced it is. So therefore, AI is intelligence, but AI doesn't know the existence of itself. So it has no self-awareness. And if the thing has no self-awareness, why is going to maximize its own benefit, right? So that is the underlying philosophy, and we can have a great discussion about it. But my personal opinion is, AI is not going to take over the world unless the current development AI is solely based on intelligence, but no AI has self-awareness. So that is going to be hopefully an interesting discussion. Another misperception, I would say, is AI taking away jobs, right? It has been on the headlines for many times, but I really want to draw an analogy from the Industrial Revolution, right? So we learned about, the Industrial Revolution emerged first from Britain and other European countries, and at the very beginning, our humankind know how to create machine using machine, right? And that was the revolution. We can use steam engines to power a train. We can for the first time, use machine automatic loom rather than human powered loom, right, for mass production. But then, well, at that time, people were worried about machines are taking away human jobs, right? To some extent, it might be true because some really labor-intensive, tedious jobs were replaced by machines. But, well, actually, the Industrial Revolution leads to not a shortage of job opportunity, but really greatly expand or exponentialized the job opportunities. Right, and suddenly we need a lot more people to be engaged in those less repetitive, more creative jobs. And, well, same analogy here. If we consider, say, Amazon, which is a huge adopter of AI technologies over the last 10 years, from 2010 to the last year, 2021, and then, well, when Amazon adopted new AI technologies, we would say, well, they're going to replace their employees. But look at the data here. So at the same time, when AI was widely adopted in Amazon, the job opportunities, the new jobs were created, and the Amazon's employee number skyrocketed over the last 10 years. And now you may ask, okay, so you talk a lot about AI, but really, what is the difference between AI and traditional, say, software programs or rule-based algorithms, right? We call those algorithms as symbolic AI because they are not the modern AI we talk about. So actually, the key difference is very easy to understand just by taking a look of this graph. So for classical programming, what they try to do is we need to supply the rules, how we are going to manipulate the data, and also the data itself into the classical programming, and the program is going to output answers, right? Whereas in modern AI, or we say categorized by machine learning, what it's doing is it asks for the data as the input as well as answers. And then the machine learning algorithm is going to output the rules. If I ask you which one is easier, supplying the rules and data is easier or supplying data and answer easier? So obviously, the rules are much more difficult to write, if possible at all. If I ask you what rules you have to write in order to translate German to English, well, probably you are going to take a lifetime to figure that out, if that's possible at all. Right? Because there's just so many nuances, there's so many contradictions in those rules that it's almost impossible to write any successful algorithm to do the translation. But if I use a machine learning model, I supply the English paragraphs, I supply the German paragraphs, and then I train the model. So the model are going to make the rules and apply those rules for the new unseen English or German paragraphs. So that is why AI is skyrocketing, because how easy it is for human beings, for us to train a machine learning model versus a classical programming model. And I want to really nail down this idea by giving another example. Say we want to invent a spam email screener. Now, almost all of us have an email that a spam email screener in your Outlook, in your Gmail, that is powered by AI. And what underlying is the following. So for example, if you want to develop a spam email screener using the rule-based traditional programming, you have to write the rules. Maybe one day you come with the rule that any email with 3 question marks, or exclamation marks, or contain the word of lottery and win, those would be more likely to be spam emails. Okay, but then, well, the next day the trend changes, right? Maybe there were new, type of new stream of spam email that do not contain those symbols or those words, and then you have to write another rule, right? And the rules keep expanding and also conflicting with each other. But then, if you develop a machine learning powered spam email screener, you just supply 2 things. One, the spam email, and some regular email. And the second, you label each email. Is this a spam email? Is this a regular email? And then you feed that into a machine learning model, and the model is going to do all the remaining tasks for you, come with the rules, and solve contradictions, and then make predictions. And if there are new emails, spam emails that do not follow the pattern, just train the model once more, right? Use more recent spam emails to train the model again. The model is going to self-learn and then adapt the rules to the new situation. And if we talk about the landscape of artificial intelligence, machine and deep learning, I know those are the buzzwords, and what really are different and similarity between them. So if we consider AI as an over-encompassing concept, including both symbolic AI, basically rule-based programming, as well as the modern AI, mainly machine learning. And then the machine learning would be, I will call them modern AI, is a subcategory of AI. And then deep learning is a subset of machine learning. So that is the relationship between AI, machine learning, and deep learning. And you may ask, what is really the difference between machine learning and deep learning, right? So the machine learning often are called shallow learning because it's usually used on tabular data. Tabular data means, for example, if you have an Excel spreadsheet, you have a number of columns, number of rows. So that is the most traditional data type we have. And machine learning, because it's called shallow learning, that is in comparison to deep learning, because, well, the algorithm is just going to evaluate the entire data once and for all. Okay, there's no layers of those representations. Whereas in deep learning, the deep learning uses the so-called artificial neural networks, and they can handle more complicated and traditional so-called big data. For example, images, videos, audios, speeches, text. So those unconventional data that are not readily analyzable by the traditional statistics or regression tools. And here we see a graph of the deep learning. So basically the inputs would be whatever, maybe the images, maybe visuals, audios, or free text. And then the input go through a number of hidden layers. So each this purple dots represent a single artificial neuron, and we can construct a number of neurons, and those neurons interact with each other through the learnable weights or parameters that can be learned from the algorithm themselves. And then on the output represented by the red dots are, for example, the targets you want. Maybe you want to do a translation, then the input would be, say, the German language, output would be English language. If the inputs are images, and then the output probably would be labels of the images. If the inputs would be, say, audio recording of a speech, and then the output would be the transcript of the speech, right? And because we can use multiple layers of neurons, we can represent arbitrarily complicated nonlinear relationship between the input and the output. So that is why we call the neural network as deep learning. And that is the difference between machine and deep learning. And there are different types of AI systems. Very generally, we can classify AI system into 3 types. We have first unsupervised learning. So basically, the model is going to learn with data only. We don't need to provide any label for the data. For example, you supply images of a cat and dog to the machine learning model, but you do not tell actually which image contains a dog or which image contains a cat. And then the machine is going to figure out the differences between the cat and dog themselves. So that is called unsupervised learning. And we also have supervised learning. So the idea is that we need to provide, for example, not only dog and cat images, but also we have to label those images. We tell, okay, this one image is a dog, this another image contains a cat. So basically, we provide both the data as well as the label to be trained in the machine learning model. And the third type is called reinforcement learning. So the machine is going to learn by incentives. Consider how a 1-year-old baby learned how to deal with fire, right? Say every time, for example, our baby walks to a fire, we have to stop the baby and then tell the baby, you can't do that, it's dangerous, right? That the baby realized the critical danger of approaching the fire. And then whenever the baby goes to say a milk bottle, and then when we give some positive incentive to the baby, right, to welcome the baby's behavior. So over time, the baby is going to learn not to approach the fire, but approach the milk bottle when the baby is hungry, right? And similar, we can train a machine like this. So say every time when a agent, say AI-powered agent approaches the fire directly, we'll give a negative incentive. Basically, we give them a say negative 10 points, right? And then every time the machine grabs some water to pull out the fire, we give the machine 100 positive points. And the goal for the agent is programmed so that the agent is going to maximize the total incentive over time. Guess what? Well, the machine is going to learn the lesson, and by design is going to learn what to do when it sees a fire. So that is called reinforcement learning. And well, if we talk about the landscaping of AI models, they are getting bigger and they are getting smarter over time at a really exponentially increasing speed. Now, take example of the language models, right? The language model can accomplish a lot. They can now write poems, essays, even help you program, and chat with you, answer your questions, do the translation. So all those really big AI-powered language models, they are evolving so quickly. So, for example, 10 years ago, when the Google issued the Albert base, which is a preliminary version of neural network model for for language translation and prediction, it has 12 million parameters. Okay, and see how quickly it evolves. All those bird model, robot model, robotic model. So those models all have the Sesame name, right? Sesame Street names. That is a very interesting feature of if you learn about natural language processing, you have to know about the Sesame Street characters. And then look at the GTP model series developed by OpenAI. And the recent model, the GPT-3, got an astonishing number of parameters of 175 billion parameters. So that is almost comparable to the total number of neurons in our human brain. That is how large it is. And then, of course, it can accomplish so much, right? In those natural language tasks usually performed by human beings or even human professionals. And if we talk about applications of AI in health and social sciences, here, of course, this is a very immature, inconclusive list, right? So AI has been applied in so many different domains that we only here pick a few is really the tip of the iceberg. For example, AI has been used to analyze images and diagnose disease using CT scan images or MRI images. AI has been applied to inpatient healthcare. For example, just last semester, a researcher, a German-based company, a researcher reached out to me, and they were having a demonstration in the School of Medicine at WashU of an AI-powered machine to lift critical EU patients from one bed, from one dorm to another bed in another dorm. And that is just one of the so many uses of AI in healthcare. And AI can be used to predict the onset of disease, say stroke, cardiovascular disease, fall, right, and many others. And AI has been used extensively in doing sentiment analysis and trend analysis using social media data, Twitter, Facebook, Instagram, to constantly track the change in sentiment, the change in emotional changes, the buzzwords, the new the new headline, all those really transcend rapidly evolving issues in the social media. And AI can be used in theme and topic identification and synthesization. One example is some researcher analyzed the topics of in the last 100 years of New York Times articles. Right, so that is think about for human beings, how many years you have to spend to just read those articles of 100 years of New York Times, right? But machine can do that for you, and machine can come up with pretty good topic identifications, by reading those huge volumes of text data. And AI has been used in therapeutic and social chatbots. No, nowadays, we usually believe that the AI models can do really some basic cognitive tasks, replacing repetitive jobs. But who could think of AI now actually are doing a lot of jobs that only years of training of practitioners can do. For example, psychologists and psychiatrists, by providing mental health consulting, right? And many therapeutic chatbots, for example, tests, are doing a lot of those type of diagnosis and chatting and clinical intervention with patients 24/7. And I want to spend the rest of the time talking a little bit about the common misperceptions, because I observe over the years, they are really the potential barriers for people to learn about AI. Right, people are scared away, and people don't realize AI is for everyone, but think AI are too difficult to learn. For example, involve too much math and statistics, involve too much programming. I'm not a programmer, and involving too much data to be useful. I have to supply, say, tens of thousands of data to feed the machine learning model in order to create something useful, but I don't have resource, nor do I have the expertise to collect those data. So AI is not relevant to me. And some will say, oh, AI is too expensive. It usually involves computation resources that are beyond my budget. It asks for GPU-powered supercomputers that I do not have. So I have to forget about it. Or many of our social scientists, healthcare professionals, we think, well, we can't compete with professional AI scientists on the job market anyway. So no matter how much I learn, I can't compete with software developer. I can't compete with engineers. I can't compete with AI experts. So why should I start? And then we are going to demystify and really debate over those misperceptions. First, too much math and statistics. First, I agree. AI involves a lot of math and statistics. So the answer is yes, but most AI practitioners don't need to know the math and the statistics behind the algorithm. So if I ask you, you use Google search every day, do you understand the search algorithm? Do you know what is the underlying theoretical underpinning of recommender system beneath Netflix, Facebook, and Google? You don't know, but you don't need to know, right? It doesn't really interfere with the use with Google, with Netflix on a daily basis. So therefore, of course, later on when you really dig into the algorithm, you want to know more. But well, if you just your goal is not to invent a new algorithm, your goal is to use the algorithm as a tool, then for a lot of time, the simple answer is you don't need to know all the mathematical and theoretical background. And I would say for practitioners, for 99% of us who are community scientists, who are social scientists, health scientists, intuition experiences are more important, much more important than the mathematical and statistical background. For example, when I teach the machine learning model in Brown School, I mentioned a lot about the bias variance trade-off. So practically, it's very important for you to understand the concept, because bias talk about underfitting, whereas variance talk about overfitting of the model, and you want to find really some model that is in between, right, with this science and the art. But I do not teach how to mathematically prove that actually the total model variance equals bias plus variance plus irreducible error. Right? I don't think that really is important, nor that is necessary. And modern AI actually is more about engineering than math proofs. Actually, a lot of algorithms, to your surprise, they are not based on mathematical proof. They are based on trial and error. So if it works, it works. And for a lot of time, we can't even tell why it works, or we can't mathematically prove that it should work. But well, most importantly, it works. So that is really the engineering, right? We build things to work, not build things to prove. And then another misunderstanding, too much programming. So I have to say that AI programming become increasingly simpler thanks to Python and high-level APIs. Now, you won't have to be a computer scientist to know how to program in AI. Take two examples. The first example is you run a state-of-the-art random forest model, right? Which is really a very versatile model in machine learning. And how many codes do you need to write? 2 lines. The first line, define the random forest regressor, and the second, fit the model, right? Given that you have X and Y data, and that's it. Right? If you want to build, say, a neural network, right, seems very complicated, very advanced. So then that is the code there. No, I put them into different lines, but actually this is 3 lines of data. First, you need to create, using the keras, for example, a sequential model that define the structure of the model with nuances. Second, you compile the model, define the loss function, optimizer, and accuracy as the metrics. And third, you fit model with the data, and that's it. That is a complicated a deep learning model, right, with 3 lines of code. So, and you know, nowadays we have the no-code programming. It is evolving, thanks to the deep learning, the open AI, and NVIDIA. They came up with different models that actually allow you to write in English, right? So, for example, develop a neural network model to fit my say image data set, and then the model is going to be developed. The code will be presented to you. So probably, well, at this stage, it's not as good as human writing, but maybe in the next 5 to 10 years, really we don't need to write any code. It's possible. So the time is going to prove whether that is a versatile approach to go or not. And then some may also argue, well, the machine learning model needs huge data, but I don't have it, so I don't need to learn about it. But really, what we are doing now in the deep learning field, we seldom train our own model. Can we train a model with like a GPT-3 with 175 billion parameters? No, we don't have the resources to do that. It needs supercomputer. It takes one run of the model. It has a cost of over $10 million, right? We can't afford that. But the good news is you don't have to do any of that. And you can use the GPT model as a start. If I tell you that you can always use transfer learning to stand on the shoulders of giants, you are not starting from scratch. You are building a computer vision model, for example, just to supply a few hundred images, and it has an accuracy of greater than 95%. Why? Because, well, you built your model on a huge image recognition model built upon 14 million images through the ImageNet, right? And for a lot of time, you even do not need to provide any data. We call the so-called zero-shot learning because the model has been trained using the entire Wikipedia text. And the model is smart enough, it is going to figure things out for themselves. For example, in the GPT-2 model, this is I wrote the first line of code. The first line, life is like a box of chocolate, right? You know where it's come from. And then the GPT model's predicted language, I do not write it, the GPT model wrote it. It opens into itself, it fills it with life, and it's all about sharing. Do you like it? I can write a beautiful paragraph like this. And then you may argue, well, machine learning demand computer resources I do not have. Yes, most likely you need a GPU-powered computer for parallel programming. The CPU is too slow for machine training. But the good news is you don't need to pay a penny for it because there are platforms that provide GPU power for free. Google Colab and Kaggle are 2 of them. There are many more to come. And also the AWS from Amazon, the Azure, the Google, they offer very affordable cloud computing at a very low price. So nowadays, I even won't have to have my own computer. I can use an iPad. I can use whatever junk computer to do my data storage, to do data manipulation, machine learning. as long as I can access internet. That is the only requirement. As long as you can access internet, you can access those Google computing resources, you can do a lot of machine learning, any of machine learning, actually without even having any working computer. And then the last sort of you can't compare with AI professionals, AI scientists on the job market, no matter how hard you learn. But my argument is you may never need to. Because the job market really value nowadays with people with interdisciplinary background. For example, people with a public health degree, with a healthcare experience or social work experience, but also a data scientist, right? Know enough to apply machine learning models. So how many times have you seen that you have to compete with a software engineer? And how many times you have seen that in a hospital setting or in a clinic setting or in social work setting, you are competing with a statistician or engineer? Seldom, if no at all, right? Because we are still competing actually in our main substantive area. But having a data science background is giving you a relative advantage. You can be the very best programmer and a data scientist in the social work setting, in the public health setting, in the healthcare setting. That is the advantage, right? And that is the critical issue about relative advantage, not absolute advantage, right? We are not asking you to develop a new software or prove a new mathematical algorithm. We are asking you to apply those models in your own professional research and work. So you may ask, where should I start? If I'm convinced with what being said regarding the importance and urgency of learning artificial intelligence, there are many places we can start. I teach several courses here at the Brown School, but also I want to spend a little bit time talking about a new program that I'm going to offer in fall 2022. Is a certificate, postmaster certificate program entitled Artificial Intelligence Applications for Health Data. So you can take a look of the link to know more about this program. So this program really addressing the demand from professionals or students who are going to want to learn more about artificial intelligence, but have little or no background, either programming background or AI background in general. So the program is completely running online. It's an online only program. It takes 15 weeks. 15-week program include meetings every Wednesday evenings. So we choose this time intentionally because that probably work well with working professionals from 6 p.m. to 9 p.m. Central Time. So every week we are going to meet 3 hours from August 31st to December 14th. So if you are a public health practitioner or social worker, you can definitely earn continuing education credits from this certificate program. And if you have questions, of course, you can reach out to our Brown School staff who are more than willing to tell you more about the details in how you can apply, what is the timeline, what are the requirements. So the program contents, we have a total of 15 weeks, and it's going to be very, very intensive, but very applied. We are not going to talk a lot about mathematics or statistics, but we are going to really spend time giving you real world examples, giving you enough for you to apply those models, those artificial intelligence models to your own setting. And although we are going to use majority public health and medicine data, but well, AI as a general technology can be applied to many other sectors. The models you learned are going to be readily applicable to many other fields. And for the first 2 weeks, we are going to start from the very basic because we know many of us do not have the programming background. So we are going to talk about giving you an overview of the AI and how to learn to code in Python. The reason why I choose Python is because Python is the programming language to go for machine learning. I know sometimes we use R, SAS, Stata, SPSS. Those are great programs for some of the data science projects for statistics, regression approach, but really you are going to hit the ceiling pretty soon if you use R and other programming languages for machine learning. So for artificial intelligence models, Python is the #1 language model to go. And we are going to spend in the first 2 weeks, learn about NumPy and Pandas to do data wrangling. Those are really the most popular packages in Python to do data science. And we are going to use Matplotlib to do data visualization. So in the first 2 weeks, you are going to learn enough for you to carry on to the machine and deep learning. And from weeks 5 to 7, we are going to really cover a great ground on machine learning. We are going to learn first, as a motivated example, we are going to talk about an end-to-end machine learning project using scikit-learn, the most popular package in Python doing machine learning. And then we are going to talk about classification tasks, regression tasks, how to train a model, how to validate a model, and then we'll move on to specific machine learning models, from the basic ones, classic ones, to really state-of-the-art ones that win the machine learning competitions in recent years. So the classic ones, for example, support vector machines and decision trees, and then the state-of-the-art ones using, most of them using ensemble methods. For example, you probably have heard random forest or XGBoost, which are great programs that are very versatile in many situations. And then we won't stop there. We'll keep moving on to talk about dimensionality reduction and unsupervised learning to even sharpen your understanding about machine learning applications. And for weeks 8 and 15, we'll move on to deep learning, the neural network, which is really the frontier of artificial intelligence. We'll start from the basics, talking about neural networks, what is the pattern of neural network, how it is learned using algorithms, and then we'll move on specific applications. So we are going to cover probably most of the prevalent applications in deep learning, including computer vision. In the computer vision, we will talk about image classification, object detection, and image segmentation. Though those techniques are actually used, for example, in self-driving cars, autonomous vehicle. And then we'll move on to time series forecasting and recommended system, which is the backbone for the Google and many other search engines. And we'll also move on to natural language processing, especially how natural language processing model has been used in the sentiment analysis that we talk about, text summarization, question answering system, chatbot, and language translation. And we'll not stop there. We'll even move to the frontier of generative deep learning. For example, how we can train machine learning models to create non-existent images and new text paragraphs. And finally, we'll also cover a hot topic nowadays, synthetic data generation, which really bypass a lot of confidentiality reasons, right? If I ask you, actually, you won't have to use the confidential data, as long as you can train and create your own data set that has the very same statistical property as the confidential data, and use the synthetically generated data for your analysis. Won't that be brilliant? And in terms of course format, we are going to have a seamless conjunction of lecture presentations and hands-on lab sessions. We are going to combine them together seamlessly using the so-called Jupyter Notebook or Jupyter Lab. And everything is online, so we are going to use the free resource, the Google Colab, with free GPU computing. We will do all experiments there, so you can share your code so easily. You just share with your Google Drive. And all the code will be provided as templates for AI model prototyping. Actually, you will be amazed how much you can use the existing code as a template. In many user cases, actually, you only change the code minimally to orient to a new task. So that is reason is critical for you to compile a large number of those data processing and modeling templates, so you can easily use and reuse down the road. And of course, we are going to give you weekly assignment, focusing on applying AI models to address real world problems. You are going to work with real world data. You are going to focus on application. You are not going to be tested on theoretical background, because entirely we are AI practitioners. We only care about AI application. And there are admission prerequisites. The applicants should hold a master's degree or higher from accredited university. Students near completion of their master's degree should discuss applicability with us. And no, the other requirements are really minimal. The applicants should have access to computer and internet access. So otherwise, we can't really connect to you online, or no, you cannot use the Google Colab. And of course, you need to comply with all the WashU regulations in terms of the vaccination. Otherwise, you can request or obtain a waiver. But that is just the prerequisites for the admission. And just to quickly recap, today we cover a really extensive ground, talking about the AI is already everywhere. We are warned by the AI divide. The rapidly increasing labor market demand for interdisciplinary data scientists as us. And AI may be easier to learn than you thought, owing to open source high-level APIs. And I would really encourage every one of us to better start learning AI sooner rather than later. So that is the end of my presentation, and I'm open to any questions, comments, suggestions. Thank you so much for your attention.
Thank you so much, Rupan. This is like, I have been attending as a co-host all of your lectures on all of the AI series, and this is like really coming full circle, AI for everyone. So this is great. So I know we only have like a minute or two left, and I'm not seeing questions on the chat, but maybe we can throw one in if that's okay. So Rupam, you were earlier talking about deep learning, and how you also talked about the mention of deep learning as part of the postmaster certificate program. And I have background in qualitative methods, so I was just curious, like, what are the opportunities for deep learning and some of the qualitative methods where we look at text, images, audio stuff? Like, what are the opportunities for those two to come together, and how much, how quickly can we start using AI in qualitative research?
That's a great question. Actually, we can spend days talking about this. This is really one of the frontier of deep learning. Now, I'll give you some example. So some student ask me, I have a transcript of 10 interviews. Should I use AI? The answer is no, you shouldn't. AI is great, but AI is not for everything. So if you have 10 transcripts, then why not just do using grounded theory, right? Using a semantic analysis and try to synthesize the data. And I believe that we human beings can do a better job than machine learning, right? But on the other hand, if you have 1,000 transcripts, how you are going to do without some machine learning models, right? It's almost impossible. So basically, when you have a huge volume of data that human beings are too labor intensive to, for example, generate topics, synthesize the data, make a summary, make sense of data, then that is where the AI is going to shine. Another example, actually, this is a great topic. In terms of saturation, right? In qualitative science, we often argue, well, how many interviews do I really need to get a generalizability, right? 12, some will argue 12, some argue 6, some argue 20, but really, what is the limit? And AI can help here. And no, I haven't really seen any application, but this is just my personal research idea. So how about, if we collect really a large number of interviews on a topic, and then we use machine learning to guide us, to what extent, how many interviews would be enough to saturate the themes, so we can stop. Right? A lot of great topics here, but really a wonderful question.
So we are nearly at time, but before we call it, a member of the audience was excited about the topic, interested in any referrals that you have, like if they wanted to get started reading today or visiting websites that you think are helpful. Are there a few books, articles, or other resources that you would point somebody to just, start the exploration?
That's another great question. Yes, I would say no, we don't have time to cover the textbooks. There are no hundreds of textbooks on deep machine learning, but I would tell you most of them are junk. So that is the reason you need to pick the right textbook. Otherwise, you are going to be really misguided. So I have a collection of textbooks that I read from the first cover to the end, and I critically evaluate those textbooks. If you're interested in that, just shoot me an email, and I can recommend those textbooks, those online tutorials, those other courses to you.
That's perfect. Thank you so much. So just by Googling Rupang's name and Washington University Brown School, that will pull up his faculty page, and his email is there. And y'all, we filled an hour so quick. I have the sense that we're actually just getting started in some of the momentum we might have about this conversation. But Rupang and Simriti, such a joy to do this program with you. Grateful to the audience for their attention and their questions, and wanting to be respectful of everyone's day. We're going to close it here. Wishing everybody a healthy, safe, wonderful rest of your day. Go grab yourself some sunshine if you can, and we'll hope to see you at another open classroom very soon. Take care, everybody. Goodbye now.
Thank you, Janice. Ready.